alcohol.
What type of reaction is this? Is this a radical reaction?
No.
No.
No, what type of reaction is this? This is called an
Hetero,
acid. No, this is called an acid-base reaction.
acid-base reaction, gotcha.
What do you
Paralytic. Because it has the two dots, right?
No, catalyst has nothing to do with the dots.
Crazy.
This is
Which was gonna
acid-base,
say
guys,
no.
yes?
Yeah.
You see a negative charge is a base, the other one a nucleophile, blah, 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 acid-base.
Most of the things are just acid-base reaction. Everything's probably. Yeah, that's pretty.
So you guys like the video?
Yes. A lot.
Now we like the video.
Now this is a class that you don't have, right? And now this is a class that you wanted to watch the most.
But I didn't write anything down,
Okay.
Professor.
Now what? All right, so here.
Excuse me.
So what's going to happen is CH3 with the minus is going to do what? What is it going to do, Karen? Sandoval, what is it going to do?
Something.
Hmm? It is going to attack
Attack
this,
this, yeah, and that's gonna go up,
and the
Make it
electron
look,
pair is going to go down.
making that negative,
Just like it did before.
yeah.
Who's taking pictures?
I'm recording, no, I'm recording now. Yeah, now I'm recording. Yeah, that's what I'm telling you. She trying to make sure though.
So, CH3, CH2, with a minus charge here. Yes or no?
Yes.
Ocho.
Now, two things can happen here. This thing can either become a double bond, and then this leaves,
Uh-huh.
and it undergoes another attack, or it can attack and this act like a leaving group, okay? But let's say this is going to go like this. Let's say that's gonna make a double bond there,
And this is
and
gonna,
this is going to leave, yes?
then you got a couple kind.
No, no
No,
carbon
no,
cation.
no, I'm tripping.
So let's say that is what is formed, yes?
And then you got the double bond.
Which is this is nucleophilic too, and it will attack it again. Whatever, it's gonna make a mess. But eventually, what's gonna happen is another CH3 is going to attack again. Okay? Is this what?
2 times, okay.
Yeah, 2 times. CH3 and CH3. And then there is a water, and takes a proton from the water, and you get
Oh, no.
It's recorded. Oh, you don't want to do this anyway.
Guys, the rest of it was no big deal, yes? What questions do you have about the previous stuff? You were lost? You didn't understand anything? Yeah, I want you to give me the product to this. What's the product? This is a trick question, okay? La Viste, what do you think? No reaction. Okay, this is a what?
Nucleophile?
It's a nucleophile, which is also a
Whatever.
base.
Base,
Yes? It is a
yeah.
base. It is a base. And this is an acid.
Acid.
So if you put a base and an acid, what it's going to do is it is going to neutralize. So this CH3 from here, which is like this, is going to pick up that proton, and it will become CH4 plus this thing. So how useful is this reaction? Not useful at all. So take-home message from here is Grignard cannot be used with carboxylic acids to attack the carbonyl. Grignards cannot be used with carboxylic acids to attack the carbonyl. It will attack an ester, yes? Because an ester does not have an acidic proton here. What happened? Can I make that using a Grignard?
Yes.
What Grignard do
No.
I have to add to that ketone to get that product?
So you're gonna add
CH3, CH3, MGBR.
count on. Here you have CH3, you have CH3.
Yeah,
Okay,
yeah.
so here's the carbonyl. Yes? Is this one. This carbonyl is that. With that CH3 and this CH3, that CH3 and this CH3.
Yeah,
So I would have to cut this here, make that a Grignard, yes?
okay.
Now, the Grignard for this would be,
Exactly. Should be,
1, 2, 3 carbons, 1, 2, 3 carbons, okay? Now, this Grignard cannot be formed. This Grignard cannot be formed because of this acidic proton. So, this acidic proton is stopping this Grignard from being formed. Because once you add the magnesium, it will react with
The
the OH here, okay? So, what are we going to do? We have to use something called a protecting group. In order to perform this, we have to use something called a protecting group for an alcohol. Okay, so we gotta protect that OH on that side. Something that will not react with a base, yes? So, the protecting group we are going to use is called trimethylsilane. Trimethylsilyl chloride. Trimethylsilyl chloride is the reagent. Plus the alcohol. Which one is going to be the alcohol? this alcohol, and here there will be a Br. Yes? 1, 2, 3. 1, 2, 3. If I do this in the presence of an amine, let's say triethylamine or it's pyridine. Okay, so what is going to happen is this base is going to pull this proton off. And once it pulls it off, it's going to form what here? A negative charge here. Yes or no?
Yes.
This negative charge is nucleophilic.
Okay.
And what is it going to attack from over there?
Hydrogen.
It's going to attack the silicon.
Yeah.
Why is it going to attack the silicon?
Partially positive.
Well, because this is partially positive, also underneath carbon, so it behaves more or less the same. And this is more electronegative, so it will attack it. And when it attacks it, it will form O, silicon, CH3, CH3, and CH3, and the Br here. Now, if I add a Grignard to this, just Mg, is going to give you MgBr. And this is now what I need to add to this ketone to get, well, not that product. Is that my final product here? Hello? Is that the final product?
No.
What's the final product? The protecting group on the alcohol can be deprotected using a source of F minus. Most of the time the source of F minus is tetrabutyl ammonium fluoride. Okay? You can use H3O plus 2. And when you use this, you're going to have the OH, the 2 CHs, and the OH, which is a product you want from over there. How's that, guys? You like that? Why not? Okay, so here, I'm going to give you another one, okay? Let's say I have this. I want to protect this alcohol. Let's put a CH2Br here. I want to protect this alcohol. How can I protect this alcohol? I protect this alcohol with TMS chloride, which is
Silicon.
okay, trimethyl silyl chloride
Silyl chloride.
from silicon. Don't worry about what.
Trimethyl silyl chloride.
And then some type of amine. And what is that going to do?
Protect alcohol.
Protect the alcohol. So instead of the alcohol, I am going to write O with a silicone on it. Yes, there's a bond there. And now I can do a Grignard. Yes?
I don't understand, how come it wasn't being stopped before? How come we didn't need to protect it before?
Because you don't have.
We did need to protect it before. We always needed to protect it. A Grignard cannot work with anything that is acidic,
right?
like a carboxylic acid or an alcohol. Okay?
Mm-hmm.
That's what you have to write down on your notes. Grignard will not work with an alcohol or a carboxylic acid. So if I have an alcohol and I'm going to use a Grignard, I need to protect that alcohol. How do I make that? It's unfortunate this semester has run out. Because now is when I was ready to blast it. I had prepared a nice juicy things for you. So guys, how do you make it? From a Grignard,
Yes.
how do you make it?
You gotta protect it because you got an alcohol there.
Hmm?
TMS.
You do not protect the alcohol here because this alcohol was part of the ketone. Yes? This alcohol here was part of it. You had to make a double bond here.
Okay.
Yes?
Mm-hmm.
Now you have two choices. You have two choices. You either cut on one side or cut on the other side. Because the ketone has to be formed here. Something has to do the attack. Either this, that, or this. Yes? So let's say that what I'm going to do is this. Is that okay? What is going to attack now? The Grignard that will attack from there is
CH3, MGBR, CH3,
CH2CH3.
Uh-huh.
If that attacks, the CH2CH3 will be added here and the OH is there.
Mm-hmm.
Was there another way?
Yeah.
Isn't it the same thing?
What was the other way?
Would you add water to it? No?
What was the other way? I can make this a ketone and cut this here, yes? I can say this. Yes? If I say that, then the Grignard must have been
MGBR.
that there.
Yep.
Yes?
Mhm.
You want another one?
Oh, look.
Nice, what's the deal? You guys seem like you're... This exam is gonna be even healthier than the other exam. Okay, let's not do it so difficult. I tell you, you have to make that from here. You gotta make that from acetone. What do you need?
So CH2, CH3, CH2, CH3. Okay.
Is this stuff gonna be on next week's exam?
Yeah.
Yes, it is. Is it? No. No.
So, carbon oxygen bond, yes?
Yes.
Carbon methyl, carbon methyl. Carbon oxygen, carbon methyl, carbon methyl. I
Exactly.
gotta clip it here,
Yep.
okay? So that will become that,
Mm-hmm.
and then the rest of it is gonna have MGBR.
Got you.
I don't get it. Okay, you need to start from here, yes? So you need to find where this piece is in that molecule. Okay, this is a carbon with an oxygen on it, yes? There's a carbon with the oxygen on it. This has a methyl group here, and it has a methyl group on the other side. There is a methyl group here, and a methyl group here.
Yeah.
So I have to cut this bond to form this stuff here, which is this. I'm just going to put a double bond here, and then the rest of it, where I cut it, I just draw the same thing and put MGBR. And that's the Grignard. Well, I'm kind of tired of this, so let's go into, what are the oxidizing agents we learned today?
PCC, SORM,
No, don't look at them. I don't want you to look at them. I want you to tell me. I know what they are.
SORM,
DSB,
PCC, SORM, chrom, whatever.
Martin something.
no, that's gonna be like last test, okay? That is gonna get you an F on the next test. Okay? I want you to memorize them in order. The order in which I gave them to you. That was chromic acid, Jones, what else?
PCC,
PCC,
Swerm.
SORM,